So looking at some basic statistics on this data, the first step that we've just completed is cleaning the data, getting rid of the nons and changing the data types so that we can do the calculations, statistics calculations on them, and then saving that data, that clean data away into a CSV file. But it's worth doing some basic statistics on the data just to see what we've got and how it compares. So typically this would be doing averages, standard deviations, and maybe correlations to see if there's any correlations between the various variables or the various columns, relationships between the columns. So we can calculate a mean and standard deviation using pandas. So we can run mean and STD, and that'll give us means and standard deviations, and we can do this on our clean data. So you can see here, they're saying, quote, the results as quality equals mean plus or minus standard deviation. So quantity. So here what we can do is we can say, compute the means and the standard deviations as means and stands. So we'll run those, run that. And if we look at what this looks like, then if we look at the means, you can see here that, it's only done upload. Sorry, I need to go back. Why is it only done upload? That suggests that I didn't run that, I didn't clean it properly. Might just go back a few steps and run this. I'm sure I ran it. Then run this. Then run this. Run this. And that's better. Must have missed a step. So it only calculated, what it did is it only calculated on the upload because the ping and the download must have still been in the string format. So I must have missed a step. Anyway, so what this does is we've got, we're calculating the mean and the standard deviation for each of the three columns that have floating point values in them. So this is the mean of the ping in milliseconds. This is the mean of the download, or the average of the download, if you like, in megabits per second. And this is the mean of the upload in megabits per second. We've also got another variable here, which is contains the standard deviations as well. So then what we can do is we can create a tuple here, with some tuples, call it stats ping, where we've got the means and the standard deviations of the ping. So we grab the mean of the ping, which is this one, and the standard deviation of the ping. So if we did a standard, we've got the standard deviation as well, and we can put that in stats ping. And we can do the same for stats download, where we take the mean of the download and the standard deviations of the download, and the means of the upload and the standard deviations of the upload, and put these in stats upload. So if I run this one, and then we can print that. So because these are tuples, we can index into the tuple and get the first value and the second value, or we can just use this method to get the two values out of the tuple. And you can see here we've got average ping time is 21 milliseconds plus or minus 5, so that's our standard deviation. Average download speed is 90 megabits per second plus or minus 3, which is one standard deviation or one sigma limit. Average upload speed, 13 megabits per second plus or minus 1 megabit per second for our standard deviations. So the other thing we can do is we can work out our minimums and maximums. So our minimum values and our maximum values, calling min and max, and this basically does the same thing. So if I run this, and if I look at the format, we've got mins I'll just do mins. I won't do maxes. We run this. You can see here we've got, this time it includes date and time. So we've got minimum date, minimum time, because that actually means something. Average time doesn't really mean anything. And then we've got pings, upload and download. So our minimum ping speed was 16. And you can see that even though this is one sigma limit, 21 plus or minus 5, does that fit in? 16, 21, 16? Yeah, it does. It actually sits within that. Yep, so our ping's in there. You can see 90 plus or minus 3 for our download. This is an outlier, 58 megabits per second. It's much lower. It's outside of the standard deviation, but that's okay. And our minimum upload speed, 6 megabits per second, 13 plus or minus 1 standard deviation, but 6 is well lower than that. So these are our minimum values, and we could look at our maximum values as well. So then we're going to do the same thing. Here we did stats on ping, stats on download, stats on upload. Here we're going to do min-max on ping, min-max on download, and min-max on upload, and do mins ping, max standard deviation, max S ping. So min S ping, max S ping. Mins of ping, mins of download, maxes of download, mins of upload, maxes of upload. So we'll end up with 3 tuples, just like we did before. And then we can print the values. Let's have a look. So our minimum ping time is 16 milliseconds. Our maximum ping time is 76 milliseconds. Our minimum download speed, 58. Our maximum download speed, 92. Our minimum upload speed, 6 megabits per second. Our max upload speed is 14. So doing this statistics really gives us an insight into what our data looks like. We've got minimum values, we've got maximum values, and then we've got the means with our standard deviations. So it gives you a bit of an insight into these numeric values and how they relate to each other. Another way of doing this is to just call df clean describe, which we've done before, and this will give us our mean, our standard deviation, our minimum values, our maximum values, and also our 25 percentile, our 50 percentile, and our 75 percentile. So it gives us a much easier and simpler way, just with describe, to in one line of code. In the next section here, what they're doing is they're going to use argmin, argmax, and iloc to find the records that have the minimum and the maximum values, and iloc is like an index into the record number using the record index. So if we look at argmin and argmax, and we call this on the ping, so this will get our minimum value and our maximum value, but what it returns is it actually returns the record index that contains the minimum value, and this one brings back the record index that contains the maximum value. So if we run this, you can see here that record 217 is the record that contains the minimum value. So before, we saw earlier on, way up earlier, we saw that there was, when we did the length, where was the length? Here, 673 records in DF Compact Clean. Well, out of those 673 records, record number 217 has contains the minimum value for the ping. So we can do the same for download and upload. Argmin download, argmax download, argmin upload, and argmax upload, and we can get these in these variables. We can get the index position of the record that contains these values. Now, how do we then extract those records? using the index. Well, this example here sort of shows how you do that. It's creating a data frame with a column field 1 and a column field 2. And the column field 1 contains these two values, and the column field 2 contains these two values. And then they're doing a DF head, so you can see it here. So we've got field 1 that has the 0 value and the 1 value in there, and field 2 which has the 0 value and the 2 value. So how we access a field is we use this thing called iloc or lock. In this case, we're using iloc. And if we say iloc1 field 1, then iloc1 will give us this record and field 1 will give us this value. So you can see here that if we run this, it returns the value 1. If I insert another cell above, if I was to say df iloc1 field 2, then iloc1 will give us this record and this will give us the field 2 value. So if I run this here, you can see here it returns the value 2. If I change that to a 0, the value you would expect it's going to go and pull out this value, yeah? And you can see there it pulls out that value. So we can use using iloc, we can use the indexes that we've got here, these argmin upload and argmax upload and all of these index positions, like this one, argmin ping 217, to index into the record that we has those minimum values. So down here, what they're doing is they're saying, and they're using .lock instead of .iloc. It says here combination with iloc, but I don't know why, but this sample I've got here is using lock. And what we're going to do is we're going to say argmin ping, and we're going to get out the date and argmin ping time. So we want to find the date and the time of these minimum values. So the field that we're doing is the date field. And the same with this one. So we've got argmin download as our location, and then argmin upload as our location, argmax ping, argmax download, and argmax upload, and getting the date and the time values. So if I run this, you can see here it'll tell us that the ping reached a minimum on this date at this time. Download reached a minimum on this date at this time. Ping reached a maximum on this date at this time. So we can use these arguments or these location values to be able to get the record and extract that information out. The other thing we can do to look at our data is we can see if there's any correlation between the variables being ping, upload, and download. And there's a bit of a discussion here about, well, there might be a correlation between, like if the download speed is slow, maybe the upload speed is higher, or if the upload is, they might be competing with each other for bandwidth, or that if the ping speed is slow, then the download speed might be slow, for example. So there might be some correlation. And it talks about, we've spoken about this before, positively correlated means that one goes up with the other. Negatively correlated means that as one goes up, the other one goes down. And what we can do is we can do .corr and return a correlation table which shows the correlation coefficients between the various variables. So if we run this, you can see here that we've got ping, download, and upload on this axis, ping, download, and upload on this axis. And if we look at upload to ping, the correlation value is -0.46. So there's a little bit of correlation, but not that much. Upload to download, 0.08. So there's no correlation there, positive. So download to ping, 0.045. And download to upload, 0.08. So I think you looking at those values, you can pretty much say that there isn't really any correlation between the ping, the download, and the upload. So just because one goes down doesn't mean any of the others are going to go down or up. So those low correlation values essentially tell you that. And you can print those out, correlation coefficients between the various ones. So that's what they're doing here, printing them out. They're pretty low. So in this next part, what we're going to do is we're actually going to visualize the data using Matplotlib. And we've done a bit of this before, but we're going to have a look at this particular, the DF clean data set, and have a look at the various ping, upload, and downloads over time. So we need to import Matplotlib to do this. And this Matplotlib inline, it says what that does is allows us to plot Jupyter notebooks inside of a cell. So we'll run that. And our first plot, what we're going to do is we're going to plot all three things. So we're going to use subplots and plot.subplots and set up our figure and our axis. Now, what they're doing here is quite interesting. It took me a while to work out what's going on here, but they're saying DF clean time. And this DF clean time is a string, so it needs to be converted to a DateTime, PD to DateTime, so that we can feed it into Matplotlib. And but what that's doing is it's only using the time. And what this does when we convert it to a DateTime is it'll use today's date. But we're putting this into a series called T. And that's going to become our x-axis. So we're going to plot basically against times. Then on the y-axis, we're going to have three things. We're going to plot we're going to plot the DF clean ping. We're going to plot the DF clean upload and the DF clean download, but all three are going to be plotted against time, or T here. And we're going to label them. Label it ping, label it upload, label it download, and insert a legend, and then plot.show. Let's have a look. And you can see here we've got our three plots. We've got our ping, which is this one here. We've got our upload, which is this one here. And we've got our download, megabits per second, which is this one here. But interestingly enough, 1019, I just ran this then, is the 19th of the 10th, which is today's date. But the time here, 14, is 2 o'clock, 3 o'clock, 6 o'clock. So the 17, 18, 19, that's the time component. So it's done like hourly there, but it's because we've only used the time and not the date, it's defaulted to today's date, but used the time that we specified when we called the toDateTime. Interesting. So here what they're doing, they're changing the line style, and they're saying because ping measurements include large abrupt variations, it might be better visualize it using dots. So here where you look at the difference between the last example and this example, when they plot the ping, they're saying, okay, use round, use dots. Instead of defaulting to line, it's using the dots. You can see here that when we run this, the ping is using dots rather than lines. You can see these outliers, gives you a better of an idea of where the outliers are, whereas most of the pings are here. You can see this one, it's interesting, this one sort of corresponded maybe with that peak. These ones here didn't really sort of correspond with that peak very much. But at this point here, interestingly enough, there's a bit of a dip. So, but we did the correlation and there wasn't a lot of correlation. So anyway, we won't go down that path because we already know that there's not a lot of correlation. So this plot here, what they're doing is they're just basically adding some labels, time, measurement, and internet speed. So on the Y label, so we've got an X label of time, and it says hours, minutes, and seconds, but it's actually not. It's actually days and hours, but anyway, we'll let them get away with it. The Y label is our measurement, and the title, internet speed demo. And tick params label size 14. I think we had that before anyway. No, we didn't. No. So they're changing the label size of the ticks values. So let's have a look. You can see here it's a bit, the label size is a bit bigger. We've got time, hours, minutes, and seconds, even though it's not. And here's our measurement on this axis and the title, internet speed demo. In the next display example, what they're doing here is they're changing the style. They're using a style called 538 to make the graph, they're saying, more visually appealing. So they're saying here, in this example here, with plot.style.context 538, then we've got fig axis subplots. This hasn't changed. This hasn't changed. Then we've got set the x-axis, set the y label, set the title, and the tick params. And if we run this one, you can see here it looks a bit different. It's sort of a bit fancier than the previous one. So this is a theme, a plot theme, 538, which looks a little bit more fancy. In the finally, in the last example here, what they're doing is they're creating a histogram, and histogram, which is basically the frequency of the values of the numeric data. So it's looking at how many plots were at 10 milliseconds. Sorry, how many measurements did we get at 10 milliseconds? How many measurements did we get at 15 milliseconds? Or how many measurements did we get at 80 to 90 megabits per second? So with the histogram, you can sort of bin these values. It's a bit like group by in an SQL query, where you're grouping, you've got a certain number of groups or a certain number of bins. So if you look at they're using plot style 538, and here what we've got a number of plots. So we've got plot.subplots, 2 rows and 2 columns. So you can see here we've got 2 rows and 2 columns, although not all of them are being used. So AX00 refers to the first column and the first row plot, so this plot here. AX01 refers to this plot here, and AX10 refers to this one here, and then AX11 refers to this one here. I think I've got that right. I think it's rows and columns. 0001 for the upload. Yep, 01's the upload. Yep, the upload. Yep, so I got that right. So if we look at AX00, first of all, we've got histogram, and we're making a histogram out of the pings, df clean ping milliseconds, and our number of bins we've set at 100. So what this is going to do is it's going to divide our positions, our pings down to 100 bins, and then when we do the plot, it'll plot them into the bin positions. With 01, we've got same number of bins, 100 bin positions for the upload, and you can see here in the upload it's divided up to 6, 8, 10, 12, 14, because the maximum is whatever the maximum was. It was just around the end here. And then with the download, we've got 100 bins, so we've got between 60 and 100. So we've got all the bins in here. So when I run this, I'll run it here. You can see it prints the histograms, and it gives us a bit of an idea of the distribution of the data. in summary, with this lab, what we're looking at is, first of all, acquiring our data, cleaning our data by getting rid of unused columns, getting rid of the nuns, getting rid of all of the records that have nuns in them, changing the data format so we can do some statistical analysis, and then in the next section, then doing that statistical analysis with means, minimums, maximums, standard deviations, then indexing into the data to find those records that have the minimums and the maximums, and then having a look at a correlation to see if there is a correlation between the data, and then working out that there is no correlation between the variables. So, and then finally looking at different ways of visualizing that data so we can get a visual understanding of it. If you look at the difference between the actual line plots, tell you one thing. So you can see here, there's at certain times of the day you've got some changes, but the histogram plot gives you a different perspective. If you look at the histogram plot, it gives you a different perspective. It shows you that that the bulk of the ping is around 20 millisecond, 20 odd plus or minus, which we saw in the statistics. Our uploads, we're looking at typically around 14, 15, between about 13 and 15 with a few outliers. And with our downloads, above 90 megabits per second for most of our data set. So the histogram gives you a different sort of view, but quite an interesting one. So with the histogram, probably the main thing is working out your binning. So what number of bins are you going to use when you're doing your histogram calculation in relation to the data that you've got, to make some sense out of it.